Yeah. Okay, if it's possible, please enable your video. That will also help us as well. Okay, so to understand you people are listening. Okay, so the first question in front of you for today. So who is going to answer this question? Yeah. So I hope you are also attending Brainiacs quiz time. That happens on every Sunday, 9 o'clock, 9 p.m. Please attend the quiz. It will be helpful for you. Just answer it and you will be able to win prizes. Okay. So just enjoy all these things and so that the studies becomes very easier for you. Okay. So the first question for you here is the most stable carbocation is. You have the option 1 where we have CH3, CH2 plus is there. Okay. We know when positive charge comes on the carbon, we call that as a carbocation. In the second option, you can see bromine attached to CH2 and there is a CH2 plus is here. Okay. And in the third option, you can see chlorine is attached, CH2, and you have CH2 plus is here. Okay. And in the last option, you can see fluorine is attached, CH2, then you have CH2 plus is here. Now, who can tell me the answer here? What will be the correct answer? The most stable carbocation is. What is the answer? Can anybody tell? Please feel free to say the answer. Please interact. Then it will help you actually. Okay. So what is the answer? We know that here CH3 plus charge is present. So what is the role of CH3 here? What effect does it have? So we know that okay, let me admit. Okay, we know that here CH3 have plus I effect. Plus I effect means repulsion of electron. So this guy will repel electron towards the positive charge. So we know that electrons are negative charge. So negative and positive will get neutralized. That means it becomes chargeless. Charge is not there means it is becoming what? Stable. Please remember that. Stability is inversely proportional to charge. Stability is inversely proportional to charge. If charge is high, the stability is less. If the charge is low, the stability is high. This is the thumb rule, you should remember. Okay, very important thumb rule. Okay, now next option you see here, bromine atom is being connected. So bromine atom, we have learned that bromine has what effect? Minus I effect. Minus of I effect means it will attract the electrons through this sigma bond. So electrons are coming in this direction from the other atoms. So what is happening when electrons, negative charge is moving in this direction, the positive charge over here get accumulated. That means the magnitude of positive charge over here is increasing. So charge is increasing means what happens to the stability? We can say stability here is, tell me, stability here is decreasing. Okay. Now look at the next one. In the next one, we have chlorine atom is connected. So we know that fluorine, chlorine, bromine, iodine, all these are what groups? Minus I groups, correct? And who is having maximum minus I effect? Fluorine, then chlorine, then bromine, then iodine. So surely chlorine atom will attract electron in this direction. So what will happen if electrons are moving in this direction? The magnitude of the positive charge over here keep on increasing. So it have maximum charge, maximum positive charge. So surely here also the stability, what will happen to the stability? Tell me, stability decreases more. So less stable. Now coming to the last one, we know that fluorine is having the highest minus I effect, correct? So it will attract the electron maximum in this direction. So what will happen? The magnitude of the positive charge here increases more, maximum increases. So what will happen to the stability? Stability here decreases maximum. So I can say that the most stable carbocation from this is which one? Tell me. What is the answer? Rohit, tell me the answer. Exactly. Good, Rohit. Good. So first option is the correct answer. I hope the explanation is clear for you. Okay. Now let's migrate to the second question. You have the second question in front of you. The most stable carbanion is from the given option. So carbanion, we know carbon with the anion. That means carbon carrying negative charge. So in this one, you can see here CH2 with the negative charge. Then you have first option CH2, then with the NO2 is present. Now in the next option, you can see CH2 with a negative charge. But here CH2 is present along with another group, that is cyanide group. In the third option, you can see another carbanion, okay, then that have CH2 along with the carboxylic acid group, okay. Then you have CH2 minus, okay. Then you can see here more amount of CH2 units are there, correct? So its length is increasing and fluorine atom is there. Now the question here is, among the four, who is the most stable one? Now again use the same logic. Charge stability is inversely proportional to what? Stability is inversely proportional to charge. Same concept. Okay. Now let's analyze the question. Now first case we know NO2 group. What effect does it have? Tell me. NO2 group have minus I effect. So minus I effect means, you know, electrons will be attracted towards that, correct? Attraction, electron attraction is what minus I effect do. So electrons are moving in this direction. We know electrons are negative charge. So that means negative charge from here is migrating in this direction. That means the magnitude of negative charge is decreasing here. So if the charge is decreasing, what will happen to the stability? So here charge decreases. So stability, what will happen to the stability? Tell me. Stability increases. So it has good stability. Its stability is increasing. Now next one I am seeing. Oh, here cyanide is present. Cyanide also have minus I effect. That means it will also attract the electron in this direction. Now a question comes to your mind. Sir, NO2 or cyanide, which have maximum minus I effect? Please remember, NO2 has maximum minus I effect than cyanide. So this is having maximum minus I effect compared to this one. Okay. So I can say here electron will move but to a lesser speed. So I can say that here also the charge, what will happen to the charge? See, charge decreases, so stability increases, but its stability will be increasing not as fast as the first option. Now looking at the third option, I could understand there is carboxylic acid group, and I clearly know that this guy also have minus I effect. So they will also attract electron in this direction. So what will happen? Charge decreases and stability increases. Now last one, you can see fluorine. I know it has also have minus I effect, but the problem is it is at a farther distance. We know that inductive effect is inversely proportional to distance. So that means as the distance increases, the inductive effect decreases. So here the distance is high, so the inductive effect is less. So it will attract electron very slowly. So that I can say its stability is very less, I can say, compared to the others. So among the whole the options, nitro group, cyanide group, COOH group and fluorine group, who have maximum minus I effect? Nitro group. So I can easily say the most stable carbanion is option 1 is the correct answer. Is this clear for everyone? So this is a question that is intended for you to check whether you know like whether the minus I effect for different groups you are able to compare or not. This is what they want to check. Okay. So I hope it is clear for you. Any doubt in this question? Sadhana, Blazan, Mekhavartini, Ritika, any doubts? Feel free to ask. Clear, sir. Good response. Yeah. So our answer was correct. Now let's go to the next question. Try to tell me the answer for this question. Which of the following is most acidic? So we know that all carboxylic acid groups are acidic in nature, but still we can comment from the given carboxylic acids which one is more acidic, using which effects, minus I effect or resonance effect, we can make use of it and tell. So let's analyze the option 1. So you can see here carbon atom connected to 3 chlorine atoms. Okay. And you have COOH group is there. Now, how will you check acidity? I have taught you this many a times. What you need to do? First, release the H+. Release the H+. release the H plus. On releasing the H plus, what will happen? You can see here chlorine, and here also chlorine, and you will get carboxylate anion, COO minus. Now the question here is, if this species, the remaining species, after releasing the H plus is stable, then I can say this is a good acid. Why? Because if this is stable, it will not attract back the H plus. So that means it can release the H plus very fast. That is the reason. That is how we will check it. So how you check whether this is stable or not? How you do that? You can analyze this. Here minus charge is present. What is the effect of chlorine? Tell me. We know it has what effect? It has minus I effect. We know chlorine here also connected, so it has minus I effect. Here also chlorine is present, it has minus I effect. So all these guys will attract the electrons in this direction. So what will happen as a result? The negative charge that is present here, its magnitude decreases. So if the magnitude of the negative charge over here decreases, then it will not attract the H plus to here. That means this is stable. If the charge decreases, the species will become stable. So I can say first option is a good acid. Okay. Now let's look at the next option. In the next option, you can see one thing. Instead of one chlorine, there is a new member coming. Who is that? Hydrogen atom is coming. Now I can say that here, what is happening when hydrogen atom is entering here? Only two atoms are having minus I effect. Hydrogen atom has an inductive effect, that's value is equal to 0. So I can say that here magnitude of the negative charge decreases, but it will not be decreasing as like the first option. So I can say second one is a good acid, but it is not that strong acid like the first acid. Okay, now let's go to the option 3. On seeing the option 3, I could easily analyze and say that there are two hydrogen atoms and only one chlorine atom. So again, it is decreasing. Now in the last one, you can see no chlorine atoms are there. It is CH3, and we know CH3 have plus I effect. So that means the magnitude of the negative charge in carboxylate anion, what will happen to that? It will increase. So from this, I could understand that the most acidic one is which one? Option 1 is the correct answer. Is this clear for everyone? Hello, dear students. All of you are able to follow it or not? Okay, please respond. So that will make you, okay, what I could say. If you are, that's why I am enabling the video, so that you can see and ask sir why it is like that. If it comes like this, what will happen? Like that you can interact actually. That's why we should call this as an interactive session. Okay, then tell me what is the answer for this question. Who is going to answer this one? Which of the following is most acidic? So you have 4 options again in front of you. You can see here CH2 with a fluorine atom connected, and you have COOH. Okay, and in the next option you can see CH2 with a chlorine atom connected, then you have COOH. Okay, then in the next option you have CH2 with what is connected? A bromine atom is being connected. Okay, then you have a COOH. And in the last option you can see CH2 with an iodine atom is being connected, and you have COOH. So who will be most acidic? Who can say the answer? Now here also the concept remains the same. Remove the H plus. Okay, let all of them remove the H plus. Then what will happen? This will become carboxylate anion like this. Now check from the 4 which is most stable. Now I can understand that fluorine is having maximum minus I effect. So what will happen? The negative charge will come over here very fast in the case of fluorine, so that the magnitude of the negative charge here decreases very fast. Here chlorine is also having minus I effect, but the inductive effect of fluorine is higher than chlorine, which is higher than bromine, and which is higher than iodine. This is the minus I effect precedency, I can say. So here also it will attract the electron in this direction, but to a lesser extent. So I can say here if it is decreasing 4 times fast, here it will be decreasing some 3 times. Here also it will be decreasing some 2 times, and here it will be decreasing around 1 time. Okay, so who is the most stable here? I can say this compound, the first species, is most stable. That means it can release the H plus very fast. So the answer here is option 1 is the correct answer. Is this clear for everyone, all of you? Okay, good. Now tell me what is the answer for this one. Which is the most basic among the following? So what do you mean by a base actually? So we will define that. That will help you to understand. Base versus an acid. What are the basic differences or basic understanding? So better way to remember here is base are something that can donate electrons. They can donate electrons. In terms of electrons, acid is something that will accept electrons. The most authentic definition. The other definition is base is something that will accept what actually H plus. Acid is something that will donate what actually H plus. The other definition is base is something that donates OH minus and acid is something that will accept OH minus. So these are the three basic definition you should remember. Okay. Now here always remember whenever nitrogen atom comes, nitrogen atom always have lone pair. So with respect to nitrogen atom, we will always speak about something as base if this lone pair is donatable. If this is donatable, then I can say this nitrogen in that particular compound will behave like what actually as a base. But think like on what occasions it cannot donate. We can think like if this lone pair is entering into resonance, if this enters into resonance, then I can say if this is entering into resonance, then it cannot be donated. It cannot be donated. It cannot be donated. If it is entering into resonance, I can say it cannot be donated. Then that is a bad base. Clear? So this is the only thing you should remember. Now let's start analyzing the first one. Okay. I hope you are also noting down. Okay. Don't worry. All these lectures will be available in YouTube live immediately after your live session. So just subscribe YouTube channel of Brainiacs classes. You can watch it again and again. Don't worry. Okay. So let's start finalizing the options. So let's go with the first one. So you have CH3, okay, then you have CH2, then you have NH2. Now we know that nitrogen has lone pair, correct? So nitrogen has lone pair. Now if this lone pair is donatable, then I say it is a good base. Now I know that what is connected near to it? CH3, CH2, that is nothing but our ethyl group. I know that ethyl group has plus I effect. So what it will do? It will donate electron in this direction or repel the electron in this direction. So the electron density in the nitrogen atom increases. So if the electron density increases, then it can easily donate. Then it can easily donate the electrons. Then I can say it is a good base. Correct? Then I can say it is a good base. That means if you have a plus I group is connected, plus I group always increases basicity. Okay, minus I group always increases acidity. This is the shortcut to remember. Plus I group always increases basicity and minus I group always increases acidity. Okay, now let's start analyzing the next question. But don't remember like this. Always analyze the question and do it. That is what I would like to do, because you don't want to remember or anything actually. Now let's go to the first. So I understood that the first option is a good base. Now go to the next option where you have a chlorine atom and that is connected to CH2 and it is connected to another CH2 unit and you have amino group there. Now I know that again, okay, nitrogen atom with a lone pair, but here you have a chlorine atom. I know chlorine atom has minus I effect. So what it will do, it will attract the electron towards it. So what will happen? The lone pair or the electron density in the lone pair, electron density of the lone pair decreases. If the magnitude of the electron pair or lone pair decreases, what will happen? This will become less donatable. So if it is less donatable, then I can say it is not a good base. It is a bad base. Clear? I hope it is clear for you. Now let's go to the next option. So in the next option, only one difference is there. Instead of chlorine, what is they are connecting? They are connecting to nitro group, and I know that nitro group is a worst one with the maximum minus I effect. So what is happening here? It will attract the electron very, very fast. So what will happen here? It becomes more or less donatable. It becomes more or less donatable and more bad base, worst base, I can say. Now you have the next one where you have O minus is present. This is very important. Whenever you have O minus always have plus I effect. If you remember that, it has plus I effect more than even CH3, CH2. Okay, because O minus means always it has its octet already completed, so it does not need any electron further. Okay, so what it will do, it will repel the electron, so that what will happen, the lone pair electron density of the nitrogen atom increases. So I can say the most basic will be option 4 is the correct answer. Clear? Hello, clear for all of you? Yes, sir. Okay, good. So that's why this question is very good one. Most of them will give for answer 1 as the answer. They won't think like O minus. Please remember, whenever negative charge comes to an electronegative atom, its octet will be complete. It will not be accepting further electrons. So that is the reason. So you can see the answer is also fourth one. Okay, good one. Now, next question for you. Which of the following is non-aromatic? So please remember, it's very easy question. Who can tell the answer? So please revise that. Condition for aromaticity. Who can tell? I have explained in my video very well. Conditions for aromaticity. Conditions for aromaticity. So please remember, the first condition is the compound should be cyclic. Cyclic in nature. We know that all 4 compounds are cyclic. Okay, there is no start and stop. That means they are cyclic in nature. Second one, so we know the second condition is the compound should be planar. Planar means all the ring structure should be lying in one plane, or all the carbon atoms should lie in a single plane. But how will you check that? By looking at the diagram. Most of the students will ask me about, sir, we are all writing all these things in a paper, sir. Paper is in a single plane. Then how will you do that? The only thing is check the hybridization of carbon. If that is sp2 hybridized, that means its shape is planar. Planar means it is lying in a single plane. So if the carbon atom has sp2 hybridization, then I can say that it is planar in nature. Then the third thing, there should be cyclic resonance. So you might be knowing right now how to check the resonance. There should be conjugation, alternation, that is called cyclic resonance. And the fourth condition is it should follow 4n plus 2 pi electrons rule, Huckel's 4n plus 2 pi electron rule. What does that mean? You can put different numbers for n. Put n is equal to 0. This will become what? 2 pi electron. Put n is equal to 1. Then what will happen? It will become 6 pi electron. So like that it goes. It becomes 10 pi electron next time. Then it becomes 14. The thing here is you count the number of pi electrons. Okay. And what you need to do, if that number is either 2, 6, 10, 14, 18 or anything like that, then I can say it is following pi electron rule. Okay. Now please remember, with these conditions we will just analyze all the question. Okay. And you can check whether the compound is aromatic or not. We will take each question and we will analyze it. Okay. So let's start with the first question or with the first option. Yeah. Now you can see here the first one. So here first one is benzene, and you know that benzene is aromatic in nature. Okay, but let's start doing it. So you can see it is cyclic. I can say it's cyclic. Now if you see the hybridization of this carbon, it is sp2. Everywhere it is sp2. So I can say it is planar. That is also correct. Then we can see resonance, double bond, single bond, double bond, single bond, double bond, single bond. It's alternating. So we can say cyclic resonance is present. Then next one, 4n plus 2 pi electron rule. If you count the number of pi electrons, 2, then you have 4. then you have 6. So we know that 2, 6, 10, 14, 18, it like that it goes. So here we have 6, that is a number coming here. So I can say it is following 4n plus 2 pi electron rule. So all these conditions are satisfied, so this compound is aromatic. Now next one, you can easily see two rings are connected, and here also you can see double bond, single bond, double bond, single bond, double bond, single bond, double bond, single bond, double bond, single bond. It's varying. So cyclic resonance is there, cyclic in nature, and every carbon atom is sp2 hybridized. And totally how many pi electrons are there? 2, 4, 6, 8, 10. Yes, 10 is a number coming here. So this is also aromatic in nature. Now looking at the next one, that is very important. So here, if you look at the third option, you can see here with the minus charge is present and pi electron like this. Here hybridization, how to find out? Minus or positive charge comes whenever a bond breaks and go. So here negative charge is coming means this atom is more electronegative than the other atom. So if sodium is connected, sodium will move as Na plus, leaving the electron here. So this electron will come here and becomes negative charge. Now I know that Sp and there is only one hydrogen atom here. So P, this is also sp2 hybridized. Then if you see double bond, single bond, negative charge, single bond, double bond, single bond, it's varying. Cyclic resonance is there. And pi electrons you can see 2, 4, and this is also involved in resonance. So 2 plus 4 plus 2, 6. So I can say all conditions are satisfied. So this is also aromatic. Now we can easily say now the answer is option 4th one is the correct answer. Here we can easily see double bond, double bond, again single bond, single bond, single bond. So there is no cyclic resonance. And also here you have two hydrogen atoms. So its hybridization will become sp3. Here also you have two hydrogen atoms. So its hybridization will become sp3. So from this I can easily say this is non-aromatic in nature. This is non-aromatic. Clear? Is this clear for all of you? Hello?
Yes, sir.
Okay. Now tell me the answer for this question. Which of the following compounds are aromatic in nature? What will be the answer? Which of the following compounds are aromatic in nature? Who can tell the answer for this question? So easily you can see here, first one, you can see aniline. Okay. So listen. It's the last question I hope for today's session. Let's see it. So you have here like this. And I can easily see here NH2 with a lone pair. And I know this is a conjugation internally itself is present. Okay. Within the compound. So I can easily say this is what actually aromatic. Now, next one is biophenyl. So whenever biophenyl is present, that means two rings are present at separate. Whenever compounds are given like this, you should check the aromaticity for individual rings. So I can say one is benzene, other is benzene. So both are aromatic in nature. Now next one is, I can see pyridine is given because nitrogen atom is part of the ring. And you can see here again the hybridization of all carbon atoms are sp2, and there is 2, 4, 6 conjugation is present. And don't think that the lone pair of the nitrogen atom will not enter into resonance because already conjugation is present. Okay, so only 6 pi electrons are there. So this compound is also aromatic in nature. Now the last one, if you see, thiophene is given. So you have oxygen atom present there like this. Whenever oxygen atom, nitrogen atom, sulfur, anybody is coming here, always lone pair will be there. So double bond, single bond, double bond, single bond, lone pair will enter into resonance. Again, all carbon atoms are sp2 hybridized. 6 pi electrons are there. So it is aromatic, cyclic in nature, cyclic resonance is present. So this compound is also aromatic in nature. So the answer for this question will be all of these will be the correct answer. Is this clear for everyone? Hello?
Yes,
Tell me, somebody asked me one doubt. Which one to explain? Please tell me. Option third one. Oh, okay, that is this one, pyridine. Okay, I will explain, don't worry. So if I am drawing pyridine, you can see here, let me say here nitrogen atom, it is a heterocyclic compound. Okay, you have double bond, single bond, then you have like this. Now nitrogen atom always have lone pair. Now when I am checking for the aromaticity, I will look at first cyclic. It is cyclic in nature. That is correct. Okay, then I need to check for planarity. So if I am looking at this carbon atom, it is sp2. Looking at this carbon, it is sp2. Looking at this carbon, it is sp2. And even this nitrogen atom is sp2, but never check for heteroatoms. Always check for carbon atoms. This is sp2 and this is also sp2. All are sp2 hybridized. So I can say this is planar also. Now next I will check for conjugation or cyclic resonance. Double bond, single bond, double bond, single bond, double bond, single bond. So already conjugation is present. So there is no use of this lone pair. So I can say pyridine is a good base. Why? Because the lone pair present in the nitrogen atom is available for donation. It does not want to enter into resonance. If it goes for resonance, then it will enter into there and it will not be available for donation. So it is having cyclic resonance is present. Next thing is how many pi electrons are involved in resonance. We know that 2, 4, 6 electrons are there, and we know 6 is a number that is part of 4n plus 2 pi electron rule. When you put n is equal to 1, it will become 6 pi electron. So I can say this compound is aromatic in nature. Is this clear for you? Hello? Good. So I hope today's session you are able to understand something, or we have done some questions. So we will continue this. We will do more questions on the coming sessions, and please revise this chapter, and we are planning a model exams for you by September 15th or mid of September. So all of you score good marks, and you will be and I can give you an assurance you will be given wonderful gifts this time. Most exciting prizes you will be getting. Okay, and also participate in Brainiacs quiz time every Sunday 9 p.m. Okay, that will help you boost your confidence and make it as a fun program, and also share to all of your colleagues also. That will help you to bring up a good competition, and also it is very wonderful in nature. Okay, so good night. Thank you for joining the session. So next time onwards, we will be coming with more good questions, and also we will be starting our next chapter very soon. Thank you.